Oh, there we go. All right. Hey, everyone. How's it going? Getting things set up here. Okay. There we go. Looking good. Okay, hey, how's it going, everyone? We're going to be doing a review of a 4x4x4 ternary CPU simulator. What is that? What is even that? I don't even know what that is. What could that even be? I don't even know what that is. We're gonna figure that out though. That's what we're gonna do. We're gonna figure it out. We're gonna tell you what it is. We're gonna look through all the details, see what's going on there, and just plug in my phone here real quick. Then we're going to see how it works. We're going to mess with it. We're going to mess around with it. We're going to see how it works. And then we're going to enjoy. We're going to enjoy. Let's see. Oh, wait. No, wait. No, wait. One moment. I got to click some buttons. There we go. One moment. Okay. There. No. Yes. Okay. Settings. There we go. Perfect. Okay. All right. Okay, so what do we want to do here? What we want to do is we want to look through and understand how this works. What is this? What is a 4x4x4 ternary CPU? Well, it's a three-dimensional. I guess not really. I mean, it's how do you want to think about it? You can think of it like as a 64-bit, almost a 64-bit cube. What you want to do is leverage some operations on it. In the way that it's being presented right now, the way that this project is being presented is the grid, or the cube in this case, which you can see here. So you can see here on the screen, we've got a 4x4 grid, and then each layer is represented with a slider. And so you can see here each of the layers. And so now you see 64 nodes essentially. So with 64 nodes, that means that with 64 nodes, what do you even do with it? What do you do with 64 nodes? Well, you can use it as memory pointers. With memory pointers, you would sort of understand, do I want to store data here? Do I want to compare different things? Do I want to compare them? And then, so it's kind of difficult to explain because it's not really a practical setup. It's more of a, from what I'm reading here in the data and what is, let's walk through it step by step here. Let's walk through it. All right. So there is how it works. Let's kind of zoom in on this. There's a ternary not inversion, which means that we need to capture 3 of the cells and have them represented comparing to each other. Let me see here. How do we even want to explain this? I mean, it's not practical at all. It's not at all practical. So, inverts the trit by subtracting from 2. This flips 0 and 2 while keeping 1 neutral, which I was confused by. I'm like, wait, why would you keep anything? Either a state is something or it's not something. It's either something or not something. And I was confused by this because basically this is still binary. It's still binary, right? Hey, Kyle, how's it going? Oh, is it live? Oh, yes, we're live. Oh, hi. How's it going? Good to see you. Happy Thursday. We're going to walk through this 4x4 CPU, which is very strange. I don't see any practical alignment on it. Let's walk through some of the details on this. Let's walk through some. Understanding the 3D structure. All right, so this is a cube with 64 cells, 4x4x4. Each cell stores a tri-state, 0, 1, or 2. So that means that you've got essentially 64 bits times 3. Hey, Centaur, how's it going over there? Welcome on in. Happy Thursday. We're walking through this 4x4x4 grid, which each cell has a tri-state, or well, 3 bits is what we're doing because it's emulated. It's emulated, right? So 3 bits. And we want to see, does it have any value to it? I mean, as far as I can tell, there's no use for this. Use the slider below to see the different layers, right? So right here, you see on the screen, we have a bunch of... it looks pretty, doesn't it? It looks pretty. I think it looks very pretty. It's, what do you even use it for? Like, what's the point? And then there's this, I guess there's a randomize button, which I believe just changes all the bits around. Yeah, in each of the cells. For fun, not for any good reason whatsoever. There's no good reason for this. So there's absolutely no good reason for it. Hi, greetings from Argentina. Your live is great. Thank you. Hey, Gabriel, thank you. Welcome on in. Happy to have you here. We're going to walk through this 4x4x4 CPU. We're going to try to make sense of it. Are we going to find any practical application for it? I don't think so. That is, I mean, that's not like the best approach to when you're going in to see if we're going to see, to like evaluate something. Just in general, you want to have like a positive approach. Let's mess around with some of the controls. Okay. So here's an operation control. Let's zoom in on that. Let's zoom in on the operation control. All right, so we've got some operations. We've got a not, we got a cycle, and or, XOR, and nor consensus. I don't know what consensus is. I know what unary operators are, right? So you can not something, which you can just invert it, right? And then you can also, I guess in this case, you could cycle something as well. Although I wouldn't cycle. I like what I might do is change the sign, right? So if you're doing a numeric operation, you might want to change the sign of something, which is just flipping one of the bits, the sign bit in the byte, or whatever your structure is, your data structure for your number. So add with arithmetic, all right? And then subtract and multi-triad, which, wait, what's the difference? What's the difference? I don't know. Let's mess with it. So let's do a not. So we can do that here. So we've got, basically, it's going to take these cells as memory pointers, and it's going to do some comparison across the tri-states, and it's going to use one of them as an output. So operator in the first position, and then results position. All right, so I believe you could do up to 3, 3, and then 3. Is that what it's going to be? Okay, that makes sense. 3, 3, and 3. So let's mess around with this for a smidgen. Let's see what this does. Let's click execute operation. Okay, so not 0 equals 2. Let's go back down to 1 over here. So this is going to be, I believe, all right. So okay, XYZ. So this will be the first cell, which should be this cell right here. This should be this cell right here, I believe. So that would be 0, and then the output cell will be X2, which I believe would be this third cell, maybe, or is this? It's this cell here. So let's make it 3. So that would be this cell. So we've got the first cell, which is 0, 0, 0, and then there's this cell, which means if we click this execute operation and we invert it, we should see 1, 1, 1. Right? That's what it should show. That's what we should see. We should see 1, 1, 1, and not just, so we see 3, 0, 1 currently. Hey, Torva, how's it going, Torva? We're walking through the 4x4x4 submission here. And this, I don't know if this is what you were looking for when we started this hackathon. Is it? You gotta let me know. I'm making sense of what this is and what they built, and we'll be walking through the code. We'll see what the code looks like. We're also going to walk through the interface. We're going to see what the interface looks like. So we've got a bunch of zeros here, and this is the cell that we're targeting. So we're going to target the first cell, and then the last cell of the first row is this cell, which is the output cell. So if I click this execute button, it is, yes, Torva, it is? All right, excellent. Excellent, okay. Clicking this, if all my things make sense, if I understand computers, we should see a 1, 1, 1. All right, let's click it. Is it right? That did not do anything that I thought it was going to do. That did not do it. All right, so what happened there? Not 0 equals 2. Oh, wait a moment. There's another number here. There's another number. I was not expecting this. I was expecting each of the values in the cells of the tri-state to be represented as 1, 1, 1. And so instead it gave me a 2 here. So what if we drop down to over here? Let's drop down to this cell right here. Does that mean that cell also goes to 2? It does. It also goes to 2. But none of these numbers in the middle. Oh, I get it now. But be careful if you enter a number that is not possible, it'll crash. Will it? Will it? Okay. That's good to know. That's good to know. All right. So I am understanding a little bit somewhat now. So we're working in operation here, and then the 0 is the full value. And then the rows, I get it. All right, so these numbers, they're not what I thought they were. They're not some sort, I get it now. So it's 0, 1, or 2 is the state. These numbers right here that we see here on the screen, let me zoom in real quick. These numbers right here are the coordinate position. That's what that is. I got it. Yes, not 0 is 2, and not 2 is 1, which remains 1 when negated. Okay, got it. Not 2 is 0. Oh, not 2 is 0. Okay, that's what I was wondering about that. I was like, hey, wait a second. Hold on a second. All right, so if we, okay, so let's look at this. All right, so if we not this one right here, and we update this cell right here. So let's do that. Let's update that. Let's do that. All right, let me zoom out here. Let's go to 0. Let's zoom in a smidge here. Okay. All right, so I want the second row, which is going to be this row right here, the first position. I want that. So our input is 1. Our input is 1. Oh, and vertical stream doesn't seem to be working again. Oh, no, really? Darn. Let me double check. It looks good. It looks good over here. Let me double check. Connect your encoder to go live. Greetings from... Wait, I see it. I see it. It's working. It's working. Are you sure? Double check. Double check. Because I see it right here. Let me just zoom it. See? Right here. Vertical stream. Right? See right there. All right. See, it's working. I can even see it. I can see me moving my screen. You can literally see it right there. All right. So let me pull that over here. Let me bring that back in. Okay. All right. Okay. All right. It looks like it's working okay. As far as I can tell. As far as I can tell. Let me see. Okay, let's get back to it. Torva, let me know if that shows up. Let me know if that shows up. Okay, seems to be just on your end. Okay, no worries. I will double. I mean, it looks like it's working. You know what? I have another. We'll deal with it. I could check. Oh, you know what? I'll do that. Let's do it. All right. Let's do. I'm gonna double check. I'm gonna double check real quick. Oh, you found it? All right, good. All right, good. Live. All right. There it is. Okay, great. Okay. Let me close that down really quick. All right. Here we go. All right. So I want to grab this value here. So I'm going to grab this value right here, which is the first value in the second row. That value is 1. So that's the coordinate position. And then I want to put the result in the very first position. So we're going to update this. So by clicking the button and negating 1, I don't know what that's going to be. What is that going to turn into? Since it's tri-state, I don't know what a unary operator on a 1 negating that. To me, if it's binary, it would immediately put it to 0. So that would keep this cell unchanged. All right, let's see what happens when you click it. Okay, it just turned it into 1. Not 1 is 1, apparently. Apparently not 1 is 1. I don't know what that's about. I don't get it. Well, all right, let's try more. Let's do a cycle. All right. So if we do a cycle operation on the first, yes. Okay. So we'll cycle this one right here. We're going to run a cycle unary operation on this cell. The output cell will be the very first cell. Let's run that. What's that do? That brings it to 2. Oh, if we keep running it, will it change it? No, it'll only adds. Okay. So it adds by 1. It's my understanding. The cycle plus 1 mod 3. So if we grab this cell right here, which is 0, and then we have the output here, that should bring that to 1, right? So let's see. This would be the third row, second position. Okay, third row. This should turn the first cell to 0. Or no, to 1. It should turn into 1, all right? Clicking, it should go to blue. Okay. All right, we're figuring it out. And then if we go here, let's go here. Let's go over here. Let's go to the number 2. So we'll take this as the input. 2 is input. And then since we would have a flow state, if negating 1, since it can't be 0 and 2 at the same time, basically the result is 1. Oh, there you go. Okay. Okay, I see what you're describing. I get it a bit. Only just a bit. I get it. I understand. I got it. I got you. Okay. So let me read that. Reread your state one more time. Since we would have a flow state, if negating 1, since it can't be found, since it can't be 0 and 2 at the same time, it has to go to 1. Okay. Okay. We need. I got it. The operation has to proceed in some way, and that's the rules. I got it. Okay. So let's cycle. Number. Let's see. So we're going to cycle 2 as the input, and the output will be this. So the answer should be 0 if we cycle this. Oh, it's 2. Wait, why is it 2? Input's position is 0 0 is. Oh wait, I got it wrong. So let's do that again. Let's do this here. So this will be 2, and okay, that is all right. So that's that 2. That should go to 0 now. Okay, good. All right, we're figuring it out. All right, we're understanding this. We're getting this. Let's do a binary, which is going to require 2 inputs on the three-dimensional CPU. On the three-dimensional CPU, it's going to require 2 inputs. Okay, 2 inputs. So we can do two different inputs here. So let's do the first cell, and then we'll do the second cell. All right, so that would be these 2 cells right here. These 2 cells right here. Let's do, and the output cell will be number 3. Hey, Steven, you have a UDP audio stream. How can I use OBS speech to text? You do? Oh, excellent. And Sarge. Okay, so you have a UDP audio stream. How can you use OBS speech to text? I recommend using just go into there is something called OBS subtitles, and then look for my name, my username, and then it should show up. You'll see something that shows up as a GitHub repository, and it supports capturing. Here's the deal. If you have the audio stream, you would need to pipe it over to the AI model, which is going to be more challenging. This only takes direct input through the microphone. Only direct input through the microphone. So that would be that. Okay, I've got your idea. Okay, so Insarge, if you're still here, you're going to go to Hugging Face. Go to Hugging Face models and look for something called speech to text. That's it. Look for speech to text. So it's called speech to text, or text to audio. So go to huggingface.co and click on the audio text to audio models, and it will give you a whole bunch of text to audio models. There's a Stability AI, an A-Step, a Chat TTS, song generation. There's a whole bunch of things. You can do it. No wave or stream. It should work. Yeah, it'll work. You just need to do any conversion, like any kind of conversion that you're looking for, and that should totally be fine. That'll work perfectly fine. Hugging Face, go to models, and then look for the text to audio, and you'll see a whole bunch of options. You'll see a lot of options over there. It'll be great. Okay, so let's get back to our tri-state here. Here we go, tri-state. All right, so what we're going to do. Oh, thank you, bro. I will implement this, GPU or CPU based. Both. It'll do both. It'll work perfectly fine on both. You can make it happen. It'll work perfectly fine on both. Okay, so let's jump over here. I want to do a binary. We're going to do an AND operator. So 0 and 2 should be 0. That should be the output. So the position will be 2. So input position 0, 1, and the output is 2. So if I execute this, the output should be 0. Boom, 0. All right, we're figuring this out. We got it. We know what's going on. Okay, so now that we've kind of seen how this sort of works, this three-dimensional CPU, which isn't really a CPU, it's more of a memory storage system, right? And then we're running operations on it and reading data from each of the cells. And then, thanks, bro. You're welcome. Happy to help. We are also using it as output and storage. So this is all that is. All right, so Torv, if you're still here, is that all this was the whole time? Is that all that was? Because it's and then using tri-state instead of binary, it's trinary. So 0, 1, or 2. And then also it's a 4x4x4 grid of memory. Is there anything else to it? Is there anything else more to it than that? I'm actually kind of curious. You got to let me know. Let me know if there's anything else more to it. Let me do one more. Let's do another one. Let's do an OR. So if I click this, all right, so 0, 2 should equal 1, right? In the binary world, it'll equal 1. What is it going to be in the tri world? I think it's going to be 1, right? Oh, it's also 2. Okay, however that works. I don't know how it works. However that works, I don't understand. Shouldn't it be 1? I feel like it should be 1. 0 or 2 equals 2. Okay, what if 2... Let's go back. Let's see. Let's go cycle. Let's do... What if we modified this to be 1? Well, it was intended to make an actual bit system that... where you can just give it tertiary values to compute, but it was just too much to do. Got it. Okay. See, what you're describing, Torva, I figured it was more like along the lines of what we were looking for, right? I figured, because it seems like there's some advantage here. Like I wasn't understanding. I was thinking, oh wait, could there be more to it? It seems like there is. And what we were presented here in this project, it seems like it got part of the way there. Hey, Quantify, go on and welcome on in. Good to see you. Happy Thursday. We're reviewing this tri-state 4x4x4 CPU grid, running some of the operations. We're going to go through the code. The code is really simple. And it's not everything that we wanted it to be, it seems, although it got pretty far there. So let's cycle. I want to cycle position. Let's see. Let's cycle this position really quick. So I'm going to cycle this position here. So I'm going to turn that to, wait, not that one. Result position. Oh, okay. Oh, I'm just going to I'm going to self-modify. There we go. Let's self-modify. All right. I want this to be 1, and I want the first one to be 0. And then I want the output to, let's see here. We'll do an and. The output to be position 3. Or position 2, right? The third cell. So 0, 1, and 2. So, well, let's do an OR, right? We're doing an OR. Okay. Is that going to be 2 or 1? This is my question. Is it going to be 2 or 1? So we've got 0, 1, and then what's the output going to be? But this is just basically a step away from, you said just basically a step away from like basic operations and all the integrated. Only thing missing is automating the input based on 2 inputs. Okay, gotcha. That makes sense. Understood. Got it. Okay, so right now we're just directly interacting with the bits, and there might be a way, I would think, to interact potentially in a larger scale rather than individual cells. You can interact with it more on a grid or a cube level. I feel like more of a grid or a cube level, you guys. I think that makes sense. Okay. Oh wait, sometimes I just wonder, when computers didn't have the digital interface, the punch cards, yeah, and the stuff even before that switches seems crazy, isn't it? All the things that we have today that we just assume is all good and happy, all the things that we have today is so much easier than dealing with those punch cards. And wow, what a different world we're in now. It's just it still would have been fun dealing with the punch cards, right? I think it still would have been fun dealing with the punch cards. I would be into it. I'd still do it. I'd still absolutely do it. Because they're computers. They make computational. You write your program on the punch card and you run it through the program and you feed it data and it gives you an output. It's fantastic. It's the world of automation. Okay, so 0, then you tri-state OR. Is it going to be 1 or 2? That's what I want to know. Is it going to be 1 or 2? It's 1. Interesting. Okay, so we're starting to understand a little bit more. You're seeing kind of how it works. All right, I'm happy with that. I think that's fine. I think that's perfectly fine. Okay, if there's any other questions or thoughts, let's walk through this process real quick, and then we'll read some of the code, and then we'll move on to some coding challenges, and we'll do some coding challenges. I think that'll be fun to wrap up the day. We'll do some coding challenges to wrap up the day. Okay. So, okay, step 1, CPU read the tri-state values. Oh, would be fun. Yeah. Hey, yeah, Steven, here is a stack of punch cards. Yeah, all right. Routine we must run every 4 hours to keep the services afloat. I know. You'd have to stand there as a human and like feed the punch cards in every 4 hours, right? That's what you'd have to do. You had to stand around just for hours on end. Isn't that that would be a bit much? That would be much. All we have to do is keep the electricity and coolant running, and you're good to go now. That's it. In all the electrical wires. Thank you for the likes, you guys. Appreciate it. Thank you for tapping on the screen there. Okay. CPU reads the tri-state values from specified 3D coordinates X, Y, Z in the memory grid. In the memory grid. Thank you, you guys. Thank you so much. The step 2, apply the selected ternary operation using the mathematical formula for that operation. All right, that's what we did. Store the result back in the memory in the grid in a specified result position. That's what we figured out. That's what it's doing. Propagate arithmetic operations. Handle, carry, borrow by storing them in the adjacent positions. So I don't know if I don't know if we've seen step 4 happen. Have we? I don't think we saw step. Oh, there's an arithmetic. Here we go. We haven't done the arithmetic step yet. All right, let's do this. We'll do this. We'll do an add. Okay. So we'll take the first position. Let's make the first position 1 really quick. Let's make the first position 1. Update this really quick. Update this. Boom. First position 1. Okay. We'll do an add. We'll do an add operation here. I won't lie. Impressive stuff. It's pretty good. I think it's pretty good. Like given the instructions, it seems to have solved the objective. All right, let's try the add. We're going to do the add next. Okay. Position 1, position 2, and then position 3 will be the output. So 1, 1, and 2. So the value, if we execute this, the value should be 2, right? That's what it should be. That's what it should be. The value should be 2. Okay, we're going to try it. 0? Wait. No. Wait. Hold on a second. Oh, carry of 0. 1 plus 1 equals 2. Shouldn't it be 2? I feel like it should be 2. Is this a bug? Is that real? I think that's a problem. I feel like that's a problem. That seems like it's broken to me, doesn't it? To me, my logic says 1 plus 1 should be 2. Right? It's tri-state. It should at least bump up there. Okay, just a fun follow-up. Now, make a communication bridge so we can cluster them. Yeah, right? Clusters of cubes, 64 by 64 cell cube, to be able to cluster them together. There you go. I think there's another mistake. It is? It seems like it, right? It's got to be. I feel like it's a mistake. It's got to be a mistake. How do we see what you're doing specifically? Michael, in order for you to see me at all, I have to show you what you can't see. You can't see what I'm doing in order for it to work at all. So that's you'll just have to listen to my narration, and then you have to figure it out on your own. And that's the game. That's the game. You'll have to figure it out. All right, let's try a subtraction. We'll try to subtract it. All right, let's do a subtraction here. Okay, so I'm going to ball this in. So 1 minus 1 should be 0, right? All right, let's run that. And it is 0. Okay. Although I said position 2, not position 3. So it's very odd. It's very odd that is doing what it is. The result position should be here, and it's doing some sort of carry and borrow, which I don't get that. I don't understand what that is. Wait, could it be this programmed in the wrong direction? So from left to right instead of right to left? Maybe. You're right? Right? It could be the order of bits. All right, let's look at the code. So I've got the code up here. And luckily, the code is all in one file. There's a lot of files. Don't get me wrong. There's a lot of files. They're all over the place. It's all here in app.jsx. So this is the main file. There's nothing else that we need to worry about. Let's zoom in on this. Okay. Let's zoom in better, please. Thank you. Okay. All right. Don't zoom. Fine. All right. Here we go. All right. Let's do this. All right. Now we can see. What's going on. Okay. So let's do a top to bottom. Let's do a top to bottom to check to see. All right, need to study. All right, sounds good. On a break, leaving the stream. All right, well, enjoy the study, enjoy the reading, and the process of learning. All right, here we go. Init grid. This is going to create our 64 cell cube. So 4x4x4 cube, which is using some of my favorite operators. I love the map operator. I really like it. So we've got this map operator here, which is going to, basically it's a for loop. So you create an array, you loop over it, you create another array, which is going to be the row, and I guess the grid, and then you create a final array, and it looks like it's just initializing the numbers to 0 to 2, basically 0 to 2. Okay. We're using some. This is all in React, so we're using useState, grid and set grid, selected layer, operations, which will be selected with that drop-down menu, right? So we've got the operations here in our drop-down menu, and then we've got positions. So, okay, so position 1, 2, and the output result. Okay, so here's the input and output. There's the input and output. Really easy, and obviously you can update the positions whenever you click the update buttons or change the cell, which is right here. These grids right here. Zoom in on that. So that's what we're looking at right here. Pretty neat. Then we've got a log, which is going to print the computational steps. So you can see the operation log here. Show explanation, which I don't know what that is. I don't. Did we see that? Is there an explanation around here? Oh, every time I change this, it modifies this section up here, which I know because I saw ahead of time. It's grabbing information from a dictionary or an object in JavaScript, which is right here. This gives a bunch of JavaScript which populates the UI with the information based on the operation. Not, and, or, XOR, add, subtract, unary, not. I would also like a unary negation. Like, I feel like a unary negation would have been great here. I feel like unary negation. So I feel like we're missing an operator. Could be maybe here, something like that. Maybe in the arithmetic section. I think that's a piece that would have been nice to see there. Yeah, exactly. Nice. Okay, so jump over here. Okay, so what else? Let's walk through. Is there anything else interesting here? Okay, so that's what the explanation is. Looks good. Then we have a whole bunch of, I see. Very nice. So here's where the math occurs. Okay, this is where the math occurs. Interesting. So that's the ternary operations. Not, okay, weird. You know what I want to do is I want to, since I keep messing around with this in a different way, let's see if we can copy this and then open it up in my editor here. See, pb paste to, let's see, let's call it like JavaScript, I think. All right, so app.js, vi app.js. Okay, here we go. So now I can show you a little bit more easily what's going on here. Just a smidgen easier what's going on here. Okay. So these are ternary operations, which are anonymous functions or lambdas that are being defined straight on the line, which is pretty neat with this rocket arrow, right? The arrow rocket. Looking good there. Tri-state and, tri-state or, XOR. So this is a math min and max, which is not at all what I thought it was going to be. Does not seem to me. Does that make sense? The and is going to be the minimum. Okay. Hi, how's it going, H-Man? Welcome on in. Happy to see you. We're reviewing a 4x4x4 CPU, which is mostly just a storage system, and there's tri-states. So each cell has a state between 0, 1, and 2. So it's interesting that way, between 0, 1, and 2. And we're looking at right now all the trinary operations. So the trinary operation for the not, the negation, it looks like it just subtracts 2. which is very strange. So it takes 2, subtract the input cell. So that's not exactly what I thought it was going to be, although I guess that's how it works from a tri-state. This is one way to do it, I assume. I assume it's one way to do it. And then we've got an OR, which takes the max. These make, okay, I understand these. These are fine. I think those are okay. And then XOR is going to add them and then mod 3, so whatever the remainder is. And then NAND is going to be not A and B. Okay. Okay, so, all right. And then or, not or. Okay. Try, and then a consensus. Oh, if it's equal, if they're equal. Oh, interesting. So you can do like if statements. That's kind of neat. I like that. That's pretty neat. And then a cycle is just going to increment by 1. If it overflows, it's going to reset it to 0. So that's easy. And then so add them together. Multi-try. Sum A plus B plus carry in. Result plus is carry. Sum with an overflow of 3. So it can only go up to 2. It can only go up to 2 then. All right. And then we got some other operations here. It looks all good. And then in order to, I like the switch statement. In order to apply which operation, it's just going to do a switch statement based on the operation, which is the drop-down menu, which is right here on the select operation. And that is set here through use state. Okay. And where is that? Let's see. We're here. All right. Interesting. Okay. There we go. That is pretty neat. I like that. Okay. And then now the rest of it is just React. Now we're just looking at React. So it updates the template engine here. That's it. And then the value is captured through the user input here. So this is where the value is captured. So use state on the operation input, and then whatever the output value is, it is updated here, and then it's updated in the user interface. That's standard React right there. That's it. That's pretty great. I like that. I think that's pretty great. I enjoyed that. If there's anything else you want to know about it, I think we walked through it pretty well. I enjoyed this because it's clean, easy, and simple. The part, obviously, it does not look human written. Let me put it that way. Although we walked through it, it was easily readable, and the output was fine. And we do need to start adding value to computer-generated code. I feel like it still needs to add value. Although, in general, like, there is, like, because of how easy it is to generate code these days. Yeah, he told me to use some AI for it in the UI design. Nice. Understandable. We still need to, like, I believe, apply value to it because it still works. It still does the job. A human didn't write it, although we're just not used to, like, assigning value to it yet. I feel like we're still not used to assigning value to AI at this point. We're still just not used to it. So, I think that's something that we'll get used to over time. But otherwise, it's great. I think this is great. So the operation, we do the operation. We get the description. We update the positions where needed as a result, and then I believe there's also a log in here somewhere. I believe there's a log somewhere. Op description. Here we go. And then op description is updated, and it will be logged here. Perfect. Okay. Add log. Nice. And add log will just set log, which is use state, and set log should be, where is that? Log. Okay, set log is the function, and then log will be, yeah, okay, perfect. This is where it's updated right here. Nice. So it's just appended to. Clean. Looks good, clean overall. As far as I can tell, it achieved the objective, and it worked. It actually worked. Although I didn't assume some things that it did. Like the addition, I was kind of assuming 1 + 1 should be equal to. Let's try that one more time. Add. All right, we're gonna try one more time. Position 1 should be 2. I assume, right? I assume it should be, but it's not. It's equal to 0 somehow. It says it here. It says it's equal to 2, which makes sense. Although suddenly it carries 0, all equals 0. I don't know how that works. I don't know how that works. We're good to go though. I think that's it. I think we reviewed it. I think it was pretty good. Thank you for writing this. It was great. Carry is stored in the next position to the right. So 0. Oh, if there's anything left over. Got it. Okay. If there's any remaining. That's kind of neat. Let's turn this to that. Let's execute this now. So 0. Okay, let's do that. Let's turn it to 2. Carries 1. Okay, excellent. So this has to be a bug because it's not updating. It's not actually updating the output. The output cell. So this is definitely a bug right here. This is definitely a bug. The output cell should be 0. So let's take a look. The add command is definitely busted. Let's take a look at this. /add. Here's the case. The set tri-state. It's right there. So it should be working. The add result. Maybe the add result is wrong. Add results. Let's see. Add trits. Okay. Let's see here. Result. I mean, because it's not the sum plus carry in. Huh? Okay. All right. I don't see where the error is. I mean, I feel like I should be able to see it. So 1 + 1 plus carry in, which is 0. Although let's see. Let's check this. Value 1 + 2. So yeah. So it's 0. So it should be 1 + 0 should be 1. And it is not doing that correctly. Oh, wait. 0. Oh. Right here. You see it. There you see it right there. Hey, Tech Man. Welcome on in. Good to see you. Pretty late here, but hi. Hey, no worries. We're just getting started. Hey, dude. How's it going? And Schumann? How's it going, and Schumann? We're doing okay here. Things are going on. We're walking through this 4x4 CPU grid. It's doing what it's supposed to. Lots of neat things. Although the add result.carry is being updated as the update value rather than, let's see here, 0 result z. Oh, shouldn't this be result? Result. Oh, result at result.z. Wait, what? Result pose. What is this? XYZ add result. Interesting. I feel like there's a bug right here somewhere. I feel like this is a bug. I feel like this part is broken. This part's got to be broken right here because it's definitely not doing what the log is saying it's doing. It's because if you execute it, it should say, let's see here. Interesting. Okay. Oh, well. All right. I think that was a pretty good review. Overall, outcome good. Potentially a bug here, as far as I could tell. So that seems like a problem. What if we did subtract? Let's see. Let's try subtract really quick. Execute. Yeah, see, it's not updating the way I think it's supposed to. Equals 2. 1 - 2 = 2. Somehow. Borrow 1. Let's see here. All right, so let's redo that. 1 - 2 is in the carry. Oh, yeah. Okay. Just completed all my projects. We'll submit all of them tomorrow. All right. Cool, the Tech Man. I have a 3-hour exam tomorrow, and then on Saturday I have a college Ooh, an interview. Nice. An interview. Those are short. Those are infrequent these days. Good luck in the interview. You'll do great. All right. Now we're going to jump back over to our command challenges, and that will be the duration for the rest of today's stream. A duration for the rest of the stream. Yeah, it just doesn't update the original subtracted added trit. That's what it is. It's definitely not doing that. And so I feel like where it says set trit, it's just not doing it the proper way. Result position XYZ. And then the actual result, let's see, is result position Z. What is this? Where do we see that at? Okay, result, add, got it. And then this result position is, got it. Okay, so that makes sense. The add result. So this is just not working properly right here. This statement right here. This here. Okay, so this is the coordinate grid. Which cell to update, right? XYZ, no problem, easy. And then the actual result is not giving us the right result. So either this part is wrong, or the set. I feel like the add result is wrong, but it shouldn't be. It's just so simple. It's so simple. Sum plus carry in, which should be 0, 1 plus 1, and then the result does a mod 3, so it doesn't overflow. So any overflows. So it's still, because 1 mod 3 is 1. Wait, is it though? Wait, let's double check. Let's see, Python. So 1 mod 3 is 1. Yeah, so the value should be 1. And I don't understand. Although it does see, I saw the carry here. So the carry, in India, it's still a common occurrence. They test the person on literally every level. You have to be good at everything? That sounds like a lot of expectation. That's a lot of expectation. Quite a bit of expectation you got there. Just a smidgen of expectation. All right. Let's see here. Okay. I wonder, is there a button here that we can click? Okay. Excellent. Okay. Let's see if that works. All right. Let's do something like this. Okay. There we go. Okay. Let's see here. So, just kind of move it over that way so it's a little easier to see. Okay. There we go. All right. So, let's say we did that. There we go. We're good to go now. I think that was a lot of fun. I enjoyed reviewing that. I understand it a lot better now. I understand what that 4x4x4 CPU is. Essentially a grid of cells that has a tri-state 0, 1, 2. The current implementation of the project that we walked through allowed us to reference each of the cells in an operation and have an output position. We did seem to find a bug here. Let me double check here. I believe it is in the carry. So the carry is the problem. It's capturing the carry and not the result. Although right here it says the result. So that is odd. I feel like, so then maybe no, that should also, no, that should be fine too. Value. Even if you remod it, right? So if you say 1 mod 3, or mod 3, that should still be 1. Yeah, that's still 1. So that counts as a bug to me. Sort of, right? It sort of counts as a bug. So there's the grid position, and it remods it by 3. So there's some redundancy there. Why can I always something? My work is complete. All your work just last night. I completed 99% of it. You just 1% of it left. Right? You got to complete it all the way. It's always that 1% that takes so much longer, isn't it? This current implementation basically is the brain F language with a UI instead of a language, and way more restrictions. Got it. Yeah. Okay. So basically, we're shifting some bits around. We're holding states in different positions, and it's in 3 dimensions. Got it, Torva. Okay, Torva. That explains it. Understood. It is. This was, Torva, thank you so much for setting this up. This was fantastic. Actually, this is something that I never ran into in my career before, so I wanted to understand it. I feel like I understand it a lot more. I don't see anything practical with it. Don't get me wrong. I don't know where I would possibly ever use this. It is still neat, though, and a 3-dimensional grid does have uses in understanding when you're implementing other things like 3D games, 3D environments, and that sort of thing. So I still think that's kind of nifty. I still think that's pretty nifty. So we did a good job. I think and then here's where it updates the entire grid. Interesting. Okay. All right. Torva, thank you again. So now we're going to jump back over here to game. Have you tried CUDA tiles? I have not. Oh, wait. Let's check out CUDA tiles real quick. CUDA tiles, which is a better version of CUDA, right? It's a better version of CUDA, right? CUDA tiles, introduced in CUDA 13, is a new NVIDIA high-level programming model that simplifies GPU development by abstracting complex thread management. I already thought CUDA was okay. Like, I had no problem interacting with CUDA before. I thought it was fine. And now it's even easier? tile-based model. You write kernels that operate on multidimensional data blocks, tiles, rather than individual thread abstractions in single instructions, multiple thread executions. Okay. A tile is an immutable local collection of data like a subarray that threads within a block work on. Okay. Okay, so that's the data layer. Okay, so there we go. Tiles are quick. Dylan, they are? Nice. Nice, Dylan. Oh, wait, 1 second. 1 second. I've got one moment. I'll be right back. 10 seconds. 10 seconds. Be right back. Okay. Back. All right, back. See, 10 seconds. No problem. I just don't like NVIDIA at this point at all. The computer hardware prices are so spiked, especially RAM due to AI. Yeah, well, I mean, it's not... I mean, NVIDIA's capitalizing on it. You're right. NVIDIA's capitalizing on it. The demand of AI kind of is coming from everyone else, though. AI is certainly profiting from it. It's can you blame them, though, for profiting on it? I mean, they did foresee this more than 10 years ago. They foresaw this more than 10 years ago, so they kind of deserve where they're at now. No one else... Well, I mean, Google kind of was, right? They created a tensor processor, or TPU, so they invested in their own hardware as well. So Google and NVIDIA. I mean, it's monopolistic in nature. Just because they're the biggest winner. I mean, the tech man... Sure, you're right, because there's not really many competitors. We do have Amazon creating their Trainium and Inferentia. We've got Google with their TPUs. We've got AMD with their Vulkan, I think, is Vulkan. And you've got Intel. NVIDIA is definitely on the top, though. They're the ones who created GPU-specific programming with CUDA like 10 years ago, right? That came out 10 years ago. So they kind of deserve where they're at. They do have competitors. They are the leader. So they have enabled us to get this far. And I can't really blame them for winning. And yes, they're at the top by a lot, right? They're at the top by a lot. You can't really fault them for that. And it's... I mean, did you know you can compile NIM to almost any CPU target? Now you do. Yeah, now we do, Michaels. You're absolutely right. I mean, I didn't know exactly which targets were available in NIM, but so almost any target. That is amazing. I like NIM. NIM is great. NIM is like a Pythonic-like language, so it's simple, clean, and easy, and it compiles. So it's kind of got a little bit of a Go flavoring to it, although Go is a little more complex, and Go has batteries included. NIM has some of that. It doesn't have all of it. You still have to import libraries with NIM, which isn't default of NIM at all. It is great to have another compiled language, though. I do like JavaScript. I do like Python. They are usually my go-to languages. And C and Rust as well. Hey, I love their GPUs, but all their direction is no more towards, well, us, the consumers. I know, right? They're only investing in the big money now, right? The super big, like the $30,000 chips. Ridiculous. Competition in the market. NVIDIA just doing what they want now. Yeah, they are. They're doing what they want. I am the chief NIM propagandist. Are you, Michaels? Really? Are you the chief NIM propagandist? NIM is great. Okay, Michaels, let's check it out. NIM programming language. There we go. NIM programming language. Let's pull it up. Here you go. If you didn't know before, this is the NIM programming language. It looks like Python. Doesn't it look great? I like the syntax. Now, here's my thing. If Rust, with its concurrency safety and memory safety, had this level of syntax and simplicity, I would love it that much more. Don't get me wrong, Rust is still number one on my list in terms of favorite languages because of how powerful it is and how much I've been able to take advantage of it at my business and my company. NIM is great because of how easy it is to read. It's clean. It looks like Python, and it's got indentation as syntax, right? So you can see the indentation as syntax here, and then it's got variable definitions using let, which in Python you don't need to define what type of variable it is or anything like that. It's just a variable. So you got some let here. They made an iOS and Android game entirely in Nim, including the backend service. So the backend server and the front end and for mobile. Michaels, you blew my mind. I didn't know you could do that. I didn't even know you could do that. That's fantastic. That is amazing. I think that's pretty impressive. That is pretty impressive. Here, I wonder if we can do this. Can we just zoom in there? All right. Zoom in. Touch. There we go. Hey! All right. All right, we'll try that for a bit. It's going to be nice and blurry. Nice and blurry. There you go. All right. Perfect. Okay. Let's pull this over here. Perfect. Okay. So, what's the worst language in terms of logic? Well, other than like the meme languages, right? The meme languages, I would say languages like Clojure or Lisp, right? There you go. Clojure and Lisp. Probably Lisp is at the top. In terms of logic, Lisp, right? You can't disagree with that. Lisp is number one on that list. Lisp is absolutely number one. You got number one on Lisp. Let's see. It contains everything in the game backend. Nice, Michaels. Nice. Yeah, see, it's great. I really like this. It's pretty neat. So you can make it an iterator. This is neat. Most languages, you can kind of do this, but they've made the syntax interesting here. This is a little advanced here. Like this extra stuff is like understanding what the iterators, inputs, and outputs are. I get it. So you're defining an iterator with the generics. We've got some generics here, right? Is that what they call them? Do they call these generics? I don't know. I call them generics because they're just letters. Then you create a for loop, and then you can yield when it matches some condition. And this will be the output. So then you can run on an iterator. Oh, neat. So you can do a for in. That's pretty neat. Okay, I like that. That is pretty neat. So that creates some syntactic sugar, which is pretty satisfying. I really like that. Import macros and structs. Okay, so what is macro? Use NIM's macro system to transform a dense data-centric description of x86 instructions into lookup tables that are used by assemblers and just-in-time compilers. Okay. So micro to lookup table, data structure, static string, untyped. Okay, so this looks like a dictionary. Is that what we're doing? We're doing some sort of dictionary. Result, new tree, for W and split. Okay, so we've defined some instructions that we're splitting on. Result, add. I don't know what this is. I don't get this. This is weird syntax here. I don't get that. That looks very weird. What is this? Michaels, if you know, I don't understand this line here. What is that? So you're defining a couple of variables here, data, and then opcodes. So a lookup table. Okay. So oh, got it. Okay. So this is converting. Okay. So this converts like a string into an object. It looks like you can also iterate over it. Result is what every function returns. Oh, got it. Okay. Got it. So just like similar to Rust, you don't have to return a result in Rust, but usually you do. You return a result, and the result can have an error or the successful data that you're looking for. Got it. So result is a result. A variable is always the result. So you've defined the result here. Do you plan to do YouTube forever? Oh, the tech man? Forever? I don't know. We're doing it for now. So at least the plan is for quite a while. Result is implicit. That is very helpful. Thank you. So that means that this result is a keyword. It's a critical word item that is going to be mutated here. It'll be mutated in this for loop, which it split all of these elements, and then it created essentially a list that you can iterate through. That makes a lot of sense. Okay. Result is implicit. So yeah, the tech man. YouTube forever? I don't know. We'll see how long it goes. Maybe we'll get to a point where I don't know. Where it's not, it just we hit some sort of limit. If we hit some sort of limit, then we'll think about it later. We might come back to it later. though. Yeah, the tech man probably will be around for a while. We'll be around for a while. Don't worry. We're good for now. We've got no plan to leave. So we've got a bunch of plans. So we've got some coding terminal challenge that we want to do. We want to do. I want to do Flask. We'll do some Flask tutorials. I think that would be a lot of fun. Have you heard of the Mari botnet? Wait, Miria botnet. Let's double check this. I may have. Let me see. Let's see. Miria is a malware that turns network devices using Linux into remotely controllable bots. Okay, so it's a botnet malware, and then it can be used to attack. That is pretty hard. You read it. You read it like? I read it like? I did read it like. I read it like. Yeah. I read it right. I read it right. Miria is a malware that turns network devices running Linux into remotely controlled bots. Oh, Mirai. Oh, you read it like Mirai. Okay. All right, gotcha. Let's see here. Go to translate. Enter the text. Do auto detect.
Mirai.
Let's see here.
Mirai.
This sounds different.
Mirai.
Mirai. It means future in Japanese. Oh, does it? Oh, I didn't know that. All right, well then let's do Japanese. Here we go.
Miku.
Miku. Oh, all right, Miku. Yeah, that's correct. My transcription was incorrect. All right, no worries.
Miku.
All good. All right, here we go. Okay. So, future. Yeah, it means future. Check that out. It's pretty neat. Anyway, okay. Anyway, all right. So, yeah, NIM, great language. Compiles. Has a lot of great user experience additions to make functions like this operate great. Hey, DWSP, good to see you. Hey, man, random drop in. Good to see you. Do you play Minecraft? I do play Minecraft. I love it. I play vanilla Minecraft a lot. It infects routers, IoT cameras. Yeah, it's Miria. That sounds like a problem. It sounds like a problem. Someone did a very good job at exploiting the vulnerabilities of those things, didn't they? They did a good job. And now we have to beware. We got to beware, you guys. We got to beware. Okay. So now that we did that, we're gonna do a Java or Bedrock. Bedrock. I do Bedrock. I've done Java before. It was fine. I like Java. I like the sword swinging in Java just fine. Though I tend toward Bedrock. Faster, does better, doesn't have memory explosion problems. Well said. I have to go in that. Well, then see you on Monday. Have a good one. All right, the Tech Man, it was good to see you. Enjoyed to have you here for a bit. Good to have you here. We're going to go doing some command challenges next. That's what we're going to do now. We're going to see if we can solve a couple more of these. Do a reaction. You guys are similar. Do a reaction. Wait, what do you mean? What do you mean? We're similar. Do a reaction. Who are you talking about? Let me see here real quick. Let's see. Pull it. And we'll do this. There we go. All right. Pull in so you can see a little better there. Although you still can't really see it, can you? No, not really. Oh, it's got it all fine there. Here, you know what? I've got a better one. I've got a better one. No, not that. We'll just do that for now. Andre von Treeform. Wait, what is this? Andre von Houck. What is this? Oh, wait, I don't know who this is. I don't. San Francisco. I used to live in San Francisco. Softmax and AI alignment. All right. I messed up my text at the end, but good. Good night. Everyone, see you Monday. All right, the Tech Man. Sounds good. See you Monday. Enjoyed to have you here at Reddit. He's just a NIM programmer. Oh, he's a NIM programmer. Okay. There we go. We're learning new things. Thank you, Michael. Thank you, Michaels. All right. Let's see if we can jump over here and get a few of our command challenges going. I want to at least solve a couple of these, and then that will be. Then we'll be back tomorrow, and maybe tomorrow we'll do like a walkthrough on Flask. Maybe we could do some NIM programming. That would be fun. Maybe we could do some NIM programming. I think that would be pretty neat. We could do that as well. We could do some NIM programming. Okay, let's see here. Let's start. Let's jump back in this. Okay, we're jumping into command challenges now. We're heading over to command challenges. In this challenge, there are some directories containing files. Okay, so we've got some directories and multiple directories, and they also have files with different extensions. DWSP. Yes. Right. All right. Bedrock. You got it. Bedrock. Yeah. There we go. Bedrock. I love it. Want to learn modding code for it and Python? Nice. So so in Java, obviously Java mods are written in Java for Java edition. For Bedrock, what is the language to use for mods in Bedrock? Is it Lua or is it still Java? I feel like it wouldn't be Java because the part of Bedrock was to, the part of Bedrock was to do something else. Something that's not Java, right? All right. Bedrock, Minecraft mod language. What is it? Wait. Minecraft Bedrock Edition uses JSON? No. That's not a language. For its official add-on behavior and resource package. So then that's not really a language. That's a resources package thing. And C++ for the core game engine. Yes, we understand that. We get that. Unlike Java Edition where more advanced unofficial mods, inject methods. Okay, deeper level modding. Okay, got it. Making JavaScripting. Oh, use... What? JavaScript's used for scripting behavior packs? Oh, so it uses JavaScript. I thought it was using Lua, popular for custom servers. Okay. It uses JavaScript? Really? It uses JavaScript? For real? Wait. Focuses on JavaScript and JSON for simple customizations, while complex mods often rely on external loaders that code injections. Okay, got it. Okay. So it's like a very lightweight modding that you can do using JavaScript and JSON in Bedrock Edition. And then in Java Edition, obviously you're going to be using Java code, which then you could use any Java bytecode language that supports bytecode. I think that makes sense. Okay. Boom, you learned something new. Yeah, I know. Thank you, DWSP. Appreciate it. Got to learn something new. We're learning something new every day. This is great. I like it. Okay. All right, let's jump back into our command challenges here. Okay, so in this challenge, there are directories and files, different extensions. Print all directories, one per line, without duplicates, that contain one or more files with a TF. Okay, so we got part of it. So we've got it almost there. So we've got all the TF files. So this is a resuming from yesterday. So we've listed all of the files with the TF. And there's some duplicates here. So there's main. So really interesting. So all we have to do is print out Terraform, load balancer, virtual machine, and VPN. So we need those 1, 2, 3, 4. We need 4. We need 4 lines output. So what is the output it wants? It says print all the directories. Okay, so we need to print the directories without the file names. So what we can do is we can grab the directory and then eliminate the file. That's what we got to do. We got to eliminate the file. We can do this. Thank you for being you. All right, thank you. Thank you for being you. You actually motivated me to learn more Python and coding. So, hey, there we go. That's what that is. All right, sorry, type at the end. Hey, we're good. Understood. Completely understood. Happy to help. Glad there's some motivation happening there. It's like a positive outcome. All right, that's the positive outcome you got there. That's great. Thank you. Okay, so I'm going to try to let's take this part by part. Okay, so I'm going to eliminate the file name from this. So we'll grep, or could we set it out? Let's see if we can set it out. Let's set it out. S/ into file extension. There is just TF, right? So we could just say \tf, and then we could say // G. Let's see if that does anything. So that get rid of the extension. Let's also get rid of the file name, which is the file name next. Okay, let's get rid of the file name. We could do that. So we'll want anything that's not a /, plus, let's see. I think that should do the trick. Okay, that didn't work. All right, / plus. There it goes. Okay, we did it. All right. And then we also want to grab the /, // There we go. So there's the directory. Now, I believe we just say sort and then UNICQ. Does that work? Did we do it? Correct, we did it. We did it. There we go. Look at there. Check it out. These little fun programming challenges. I love these. These are great. Because, I mean, who would ever think to type something like this? Now, this is here. So if we look at the solutions, let's go back to this. All right, so let's look at the solution. Hey, Kyle, I hope you're getting paid off these ads. Maybe. This is wild. I'm actually kind of curious, Kyle, what advertisements are you getting? Which ads are you getting? Let me know what kind of ads. What are you even seeing on the ads there? I'm curious because this is like a tech channel. So what would the ads look like? That's what I'm curious about. What do the advertisements look like? That's what I'm curious about. Let's see here. Okay, so here's the deal. Take a look at this. Check this out. You know that we're doing this legitimately. Domino's? Oh, pizza. Yeah, there we go. It's lunchtime. Yeah, I got to go eat. I'm hungry, but I'm going to spend more time with you guys. So, how's it going, Gun Highs? Well, I found your stream once again. I hope you remember me. Gun Highs, it's good to see you. Welcome on in. Good to have you. Happy Thursday. We're doing some command challenges right now. We started off the stream by looking at this 4x4 CPU, and then now we're over to command challenges. Now we're no longer on that topic. We're on command. I just Googled pizza, so it's probably custom to you. It is, yeah. It knows. It remembers. Thank you. Very interesting. Thank you. I think that's like this great feedback. Thank you. All right, so this is a lot of fun. I'm enjoying this. So here's the deal. Check this out. You know that we're doing this legitimately because we are struggling. We're getting errors. And also, my solutions, they're not solutions. I'll let you cook then. Let's go. Let's do it. Check this out. This is great. I'm enjoying this a lot. So these are legitimately solutions that we're coming up with live on the stream. And you can tell because we're struggling, we're getting it wrong, and we're trying, and we're working it out step by step. So you know it's legit. And I bet if I open up the solutions, they won't look like my solutions, right? They'll be different. Okay, so they're similar. We get some similar ones in here. Do we see any sed? There's no sed in here. It's just sort unique C and then a whole bunch of other fun things that are way better than what I was doing. Look at that. Sort unique dash I. See, I don't know what some of these are. But so I was doing sed this whole time. Okay, so at least you can tell that. So there's like no sed, right? Find SED. Yep, it's only on mine. Only mine right here. Right here, only mine. Okay. So there you go. All right, let's go into the next one. Let's do the cow. We're doing the cow now. Okay, we're doing the cow. All right. We're cow mode now. We're in the cow zone. There are a mix of files in this directory that start with letters and numbers. All right, let's take a look. What do we got? Okay, so we got a bunch of named files in here. Print the file names, just the file names. Okay. Print the file names of all the files that start with a number recursively in the current directory. Okay. What? Oh, from the current directory. Okay, so there must be more directories. So let's see. Find dot dash type is an F. Okay, so here's all the files. Okay, so we see here's the file name and here's the dir name. Okay, so print the file names of all the files that start with a number. So what we need to do is we need to just get the file name, right? So how do we do this? File, let's see. Can we pipe that file name? I don't know if we can do that. No? Okay. We're gonna have to extract this ourselves. All right, so we can do that. We can do that really easily. We can do that. So this is a file name. That's a file name, right? Here's a file name. And we need to exclude the directories. That's what we got to do. Interesting command challenge. You have to try this. It's a lot of fun. I just finished Advent of Code. Oh, there we go. Advent of Code. That's another coding challenge. So that is next step to have more fun. Thank you, Stephen. Thank you. Thank you. You're welcome. Yeah, we got some more coding challenges here. That's what we're doing. All right. So what else can we do here? How do we want to do this? All right. So I would also like to do some Advent of Code. I think that would be neat to walk through those. I saw some of them. They're more involved. Each problem in Advent of Code is more involved, right? It takes a little bit longer to finish it because they're longer problems. These problems are like 1 to 2 sentences. They're 1 to 2 sentences. They're a lot easier to deal with. So they're kind of fun. They're fun and quick. They're fun and quick. All right. So let's try this. All right. So we've got our file names here. We need to extract just the file name. So let's grab that. Let me see here. Okay. I think we can do this. grep-op. We will grab, let's see, //g. We don't probably need to do that. All right. We want to end of the file name, anything that's not a / plus. And then I think, oh wait, let's grab that. This is what we need to grab here. Grab that. Okay. Can we do that? Is that all we have to do? Is that it? I think this might be it. And that should give me the file names of all the file names. Output does not, wait, that should, okay. Let's see here. I do want, okay, / capture. Maybe we have to do / here. Nope. Because it's Perl, so it should be fine. Maybe we do it like this. Okay, capture that. I know it doesn't match, but I still want to see what the output is. Let's see here. We'll get this. / Let's just say, oh, let's do something. So let's simplify it. So let's do A to Z, and let's just capture whatever that is. So there must be an error. I've got some sort of error here. Oh, maybe it's not a /. Okay. There we go. Okay, there we go. All right. And / anchor go. Okay, there we go. There we go. So here's all the files. And now we just have to capture anything that starts with, let's filter out anything that captures a number. So it has to start with a number. grep for anything that starts with a number. Okay. Beginning with a 0-9. Done. If we press enter, this should work. I believe this is the full solution if we press enter. Hey, we did it. All right, there we go. All right. We're making our way. We're making our way. We're doing it. We're doing it. We were making things happen. We're making things happen. Okay. Looking good. So that was it. That was my answer. Easy. All right. So now we're on. Well, we'll do one more. We'll do one more and then we got to get going. We're going to do one more and then we'll get going. Print 25th line of the faces file. Oh, well, this one might be too easy. Right? This wants me to print a very specific line number in a file. So let's see. Let's just cat the file real quick. I'm just going to see what that is. Faces.txt. All right. Oh, neat. Check that out. All right. So we need to print the shrugging character. Okay. So print. So we'll say. What we'll do this. Say, what is this? Head -in 25 type tail -in1. I think that's it. That's a really easy one. Oh, we did it. Hey, there we go. I think, right? That counts, right? Correct. We did it. All right, we did it. Check that out. Okay. Wait, does that mean we win? Or are we on? Oh, no, we're not done yet. We're not done yet. Okay. There's more to go. Okay. That one was too easy. That was too easy. I think we need to do at least one more. Let's do one more because that was too easy. We'll do one more. Okay. One more, you guys. All right. Print the lines of the file reverse me.txt in the directory. Reverse line order so that the last line is printed first and the first line is printed last. Okay. So what's the file? Reverse me? Okay. Cat reverse. All right. I had to type it out. reverse-me.txt. Okay. So that is the file. Okay, so we need to reverse this. How do we do that? Actually, I mean, I could enumerate the numbers. I could enumerate the lines So I'm thinking of a very complex solution here. That's a little bit involved. I can add a number of the current line number, or I've got an idea. If equals money / in for I in wait let's do this for line in file cat reverse me.txt. Okay. Do echo money line. This should be the regular order. So we should see everything perfect. Okay, so this is the standard order. What we can do is we can go the opposite direction. We could do how to do this? All right. We could use head and tail and loop through it. We could add in, so we'll echo. All right, so we'll say, here we go. We'll do L equals 0. And then we'll increment L. Echo money L. I think, can we do plus plus? I don't know if we could do plus plus. No, we have to update that separately. Okay. Money L, money line. So that should do the trick. So this will, and then we have to increment it. This is not the best solution. L equals L plus 1. So this will enumerate it. 1 second. I gotta do, done. We gotta put a semicolon here. There we go. Okay. No, we have to do this. I think we have to do this, like this. There we go. In parentheses. We have to put it in parentheses. Maybe just one set of parentheses. No? Wait. Hold on a second. Money? It's doing string operations now. Wait. Let's see here. Maybe we could do like this. Money like that. Let's see here. Yes, there we go. Okay. So now we can sort -R. Here we go. Sup, man? Hey, how's it going, Isaac? Welcome on in. We're doing one last coding challenge. We're doing it in a weird way. I think we could do this way better. We can enumerate with the sequence, and then like do a reverse sequence and then grab the line numbers. I think we could print it that way. But I'm doing it weird. I'm doing it in a very odd way. Okay, so we'll say out equals this. I wonder if we could say echo money out. Is that gonna work? It does, though. You know what? Maybe we should try it differently. Let's see here, because it is. How about we also echo /. All right, so here we'll do this. Echo in brackets like that. Space /n. Is that gonna be better? No, that doesn't. It doesn't matter. All right, I've got a better idea. Let's do sequence. Okay. For I L N SEQ 0.10. Let's double check this. We'll double check this here. Do echo money L. Done. Okay. SE. Oh, right. Okay. Let's see here. How do we do this? Money like that. All right. Let's see if we can get this to work here. I'm pretty sure we can get this to work. All right. So we're using the sequence. Is this even how we do it? Did I do it right? Invalid. All right. So maybe there's no dots. So we just do like this. All right. Perfect. And then what we could do instead of this is we can do wc-l cat reverse -me.txt. Pipe that there. So that should give us the exact number of lines. All right. And then we can use echo. How do we want it? Oh, maybe we can just reverse it like this. Let's see. Does the sequence go backwards? I wonder if sequence goes backwards. Does it go backwards? I don't know. Semicolon. Okay. So that's not printing. Oh wait, did I print that right? Yeah, for Ellen. Okay. It doesn't like that. Okay, so we do have to go in standard order. So what we could do is, I've got an idea. All right, so let's define a variable. Oh wait, let's say lines equals, and then we'll grab this here. So that way we can reuse the variable. Let's see, go here, paste that in. Okay, and then we'll do lines, money lines here. Let's double check that we got it all. L-I-N-S-E, there we go. It should print out all the line numbers, although it did have an error. All right, where is that? Okay. Oh, yeah, I found it. I see it. Okay, there we go. All right. 0 to 11, because it's 11 lines long. So we're doing good. 11 lines long. All right. And then I want to, well, instead of echo, the output, which I'll keep it there. I'm going to keep it there for now. Let's do cat reverse dash me.txt. Pipe that over to we'll do head dash n1 money lines minus L. Okay. So what we need to do is we need to reverse the line numbers. So that way I can grab the last line and do tail and then head 1. Tail head 1. Okay. I think we can do that. So let's do this. So let's do some math here. So lines minus. All right. Let's see if we can echo this out. Let's see if we can make this work. Okay. Do we have to double wrap this here? Let's see here. Double wrap it. Sometimes we have to double wrap it. Nope. Doesn't like that. What if we put a money sign in front of that? Put a money sign there. Okay. Okay. There we go. All right. So we got the line numbers in reverse. Easy. Okay. So now that we have the line numbers in reverse, all we have to do is we have to cat reverse dash me.txt and then pipe that over to head or tail dash in and then pipe that over to head dash n1. That should work. That should be the answer. I feel like that should be the answer. All right, here we go. Did we do it? Output does not match. Oh wait, we printed in the right order. We printed in the correct order. Hold on. Wait. Let's see. Lines minus L. How is that the right order? We did it in reverse. Okay. Sequence do. All right. So lines minus. So we printed it out. Okay. So what if we just did lines? No, L. What if we just did L? Let's do L. L. Okay. Oh, there we go. All right, I was making it more complex than it needed to be. All right, we did it. We solved it. Correct. You have the correct challenge. We did it. All right, here's my solution. We did it, you guys. All right, we win. We can't see your screen. All right, yeah, sorry, we can't see your screen. There you go. There is the answer. You can kind of see it. There you go. Sorry for not being able to see the screen there. There you go. All right, we did it. That was it for today, everyone. Thank you. We'll be back tomorrow. Had a lot of fun streaming, looking through the 4x4x4 CPU, which was neat. And then we switched over to the coding challenge, and we did some more command line challenge, and that was great. I had a lot of fun with it. It was great to see you all today. We'll be back tomorrow, and we might do like a tutorial of some sort, like a Flask tutorial, because a lot of people were asking for that. A lot of people were asking for a Flask tutorial, so we might do that as well. So that'll be the plan for tomorrow. We might do that tomorrow. It was great to see everyone. We're headed out now. We'll be back tomorrow. Thank you so much for spending time with me. And we'll do some more fun coding stuff tomorrow. All right, everyone. Thank you for your time. Bye. Cool. MCO doing. MC Din. Good to see you. All right. Thank you so much. We'll see you guys tomorrow. It was a lot of fun. Bye, guys. Oh, Nick Tuck. I didn't know you were here. It's good to see you. Welcome on in. Well, you've been here for a while. You've probably been here for a while. I didn't know you were here. It was good to see you. Yeah, we're headed out now. Had a lot of fun. We'll be back tomorrow. You guys. All right. See ya. Bye, guys.